Am I audible?
Yes, sir.
Is the screen visible?
Yes, sir.
Okay. So refrigeration part is over. We studied about air refrigeration, that is basic. Then VCC, vapor compression refrigeration, and finally vapor absorption. There are other refrigeration methods also available, but not very commonly employed. So we will be studying them not from numerical point of view. So I have prepared some group-wise assignments, which I will be sharing most probably by today evening or maximum tonight or maybe tomorrow. So I will form the groups. Form the groups means number of students. You form the group. I'm not going to make any kind of compulsion for which person to go in which group. But you can make it, and you will be required to collect the information. कहाँ से वो भी मैं बता देता हूँ. Prepare some kind of report and submit it. That will be considered even as a part of your TA work. Okay. So certain bits from the refrigeration part and certain bits from the air conditioning part, which are relatively simple. You can read it from your favorite friend, Wikipedia or whatever it is, and prepare a draft, show it to me. If it is fine, you can submit it. If any kind of revision would be there, you can do it. Okay, so well in advance, I will be sharing this list, and we have to do it by the end of the semester, not even MST part. So certain refrigeration processes, as I had said, which are not so common, which are not so what I can say popularly employed. They are the theoretical processes, theoretical in the sense practically also possible, but not very common, not very popular. So those techniques, how they work, how the graphical interpretation looks like, and etc. etc. So those assignments would be more like a short note. I'm not going to ask any numerical about that. It will be a short note. I may or may not ask in the EST, not MST. Okay, MST is hardly 20 marks, so two questions, two numericals, that is more than enough. For the ESC, it depends whether to take it off 60 marks or 100 marks, I don't know. Whatever decision taken by the exam section afterwards, because it would be in offline mode, so nothing difficult as such in that. So if it would be whether 60 marks or 100 marks, I may or may not ask one theory question based on these assignments. Okay, so today we start with the air conditioning. Now, how many of you have seen the domestic air conditioning unit in an open state? कभी खोल के देखा है? पतरा निकाल के? Anyone? Online class? You have not seen? Seen? Where? Ah? No. This is only the evaporator part. क्या करने के लिए? उससे क्या होगा? Okay, so mass flow rate reduces then. Your delta T reduces basically. If your m dot is reduced, naturally the cooling will not be as per the expected part. Correct? Fine. So before studying the air conditioning processes, when you start on the AC unit, then you set some temperature or maybe some humidity also, those who know how to set it, of course. So likewise, you set some particular operating temperature operating condition with the help of the control panel. And then accordingly that particular process takes place, right? Let's say you switch on the AC and you put it for 24 degrees Celsius. Outside temperature is, let's say, 30 degrees Celsius. So the process of reducing the temperature and of course any other properties also from 30 to 24, that process will start. But what is the working medium? Is it dry air? Obviously not. When we say atmospheric air, then it is a mixture of the dry air, that means oxygen, argon, krypton, helium, hydrogen, blah, 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 plus the water vapor. And this water vapor is the basic component for the humidity control. You can increase the water vapor content, you can reduce the water vapor content. So now if you recollect whatever we had learned in the chapter for the vapor absorption refrigeration, the same logic will be applied over here. So if you read the title of the chapter given, thermodynamic properties of the moist air. So moist air is treated as the binary mixture of dry air and the water vapor. So whatever we had learnt in that particular chapter, adiabatic mixing, then along with heat addition removal, whatever it is, blah blah blah. So all such things will be applicable over here. Correct? So whatever physics we had learned in that particular chapter, BAC, now we are going to employ the same logic for a working substance in the air conditioning unit, that is moist air. Now the question which I asked, has anyone seen the unit open? The reason behind that, from the online group, anyone had seen it open? Yes or no? For cleaning?
Sir, while servicing.
Cleaning, servicing, maintenance, whatever. So
Yes,
क्या देखा अंदर?
Sir, they have some filter sort of thing. So first they take it out, and there are some coils in there. So yeah, so उसके अंदर तो
the filter is in between what? There must be some circuit, na? What kind of circuit it is? Have you seen the compressor there?
Sir, I don't know actually if I have seen or not. Compressor दिखा रहे हैं.
Compressor is as same as that of the domestic refrigerator, black color. Have you seen it or not?
No, sir, there were some filter and coils only, sir.
No. In your whatever unit you had seen may not be the complete unit. For the air conditioning circuit, whatever domestic or industrial, commercial, whatever you see, the air conditioning unit, the inner circuit is always a refrigeration circuit, and that too VCC compulsory, because that is the only refrigeration circuit which is the most compact one. VAC is bulky, you need the rectifying column, you need the generator, blah blah blah. And all other processes, air, its COP is very low. So the best possible choice is the VCC, vapor compression cycle. COP is highest, compact structure, right? So the heart of any air conditioning unit is the refrigeration circuit, VCC. And in the evaporator of that air conditioning unit is the air which is getting passed on you. And then what you say is the cool air, cold air coming out. Okay. Now there is a recirculation circuit also that eventually I will explain. But just as a basic part, always remember that the VCC, refrigeration circuit, is the heart. And in the evaporator, the air will come into picture. So naturally, the air will get cooling effect. refrigeration circuit means evaporator back to the original condition, and that cold air will be thrown outside to the public, and you call it as a air cooler basically. Now if you add any particular circuit to to control the moisture also, then we call it as air conditioner. If you are controlling only the temperature, we call it as air cooler. If you control the moisture along with the temperature, then we call it as air conditioner. This is the basic difference between an air cooler and air conditioner. Air cooler किसी ने देखा है?
Yes, sir.
It's a huge tall circuit.
Sorry, sir?
It's a huge tall circuit. Am I audible?
Yes, sir. Yes, sir.
And there is a belt. It's continuously moving. It's a motor, correct? And that belt, some kind of porous stuff is there, and sponge or anything, and that gets dipped in the water at the bottom part, correct? And while moving in the upward direction, of course, in bracket with the help of the motor, and there is a fan at the back side, and that just throws that particular cold air in the room. There is no control over the moisture. So that is what is called as the air cooler. Water is at the lower temperature, so if you add the water in the air, naturally temperature reduces, we call it as air cooler. There is absolutely zero control over the moisture, correct? Because of the fan, the moisture which is getting also thrown in the room air, you do not have any control. It may be more than expected, lesser than expected, anything. So it depends on the material properties of that belt and the fan speed, of course. So if somehow we provide the control on the moisture also, temperature and moisture, temperature and humidity, I'm using specific words now, then and then only we can call it as a air conditioning. Air cooler means only temperature. Condition means you are the one who is going to condition the air as required. In air cooler, you do not have any control on the humidity. Whatever is the humidity, fine. But in the conditioning means you have to have the control on all the thermodynamic aspects. Of what? Working substance, moisture. So for this reason, we have to initially study the thermodynamic properties, how we calculate the properties of the moisture, and then we will use the same logic, same knowledge for different processes. So there you will come to know that when you switch on the AC and you put some particular button, when you press that button, then what exactly happens inside. Okay, so before that, as a working substance, we need to study the thermodynamic properties of the working substance, that is moisture. So we will start with the basic part, thermodynamic part. Eventually, we will convert all these mathematical formulae into a chart, graphical part. And then with the help of the chart, we will try to analyze all the thermodynamic processes. Fine, that will be our methodology. So initially, thermodynamic formulae, convert on the graphical interpretation, and then use the graphs for the processes. So let's see inlet condition, outlet condition. Locate both the points on the chart, read the properties directly. Need not solve all the equations again and again. The same logic which we have used for the VCC, that is pH chart, and VAC, that is HX chart, enthalpy concentration. Okay, so we derive basic equations, governing equations, convert it into suitable graphical interpretation, and then use them for solving the numericals. So as the outlines would consist of the fundamental discussion of the moisture. What is moisture? How you will define it, okay? Then I will introduce the most important temperature definition, that is the thermodynamic WBT, wet bulb temperature. We are going to do that experiment also in your lab. Then very similar to the steam table, there is a moisture table also. Steam table हमने second year में पढ़ा, refrigeration table अभी पढ़ा, correct? ASHRAE charts and tables I have shared with you. So similarly, there is a moisture table also. So I will introduce how it looks and how to read it. Then under certain assumptions, there would be an approach where you can consider the moisture as a perfect gas, ideal gas behavior. There are certain limitations, certain conditions under which only you can approximate it as a perfect gas, not everywhere. So what are those conditions? We will study. So the approximate calculations also will help you at least to get some idea, rough idea about the outlet condition. Naturally, it is having some error, so that is why the charts. Okay, and then we will discuss a little bit about the construction of the psychrometric charts, which you are going to use to solve the numericals. Okay, now these charts are called as the psychrometric charts. Psychometric म्हणायचं नाही. Psychro is different, psycho is different. Fine. So how these psychrometric charts look? Anybody from diploma? Rahul and then other people. You must have used it, correct? If present there. How many are diploma people? 7, 8? Yeah?
Yes, sir.
10, 12 diploma people? इतने नहीं होंगे? अच्छा हाँ नहीं, your old batch ना, हाँ ठीक है. Maximum 12. Now maximum 8. So you must have used this psychrometric chart.
Yes, sir.
Okay. So let us study in depth at how it is constructed and how to use it further. Fine. When I say atmospheric air, then to define it properly, it is the mixture, in bracket of course homogeneous mixture, of the gases including basically nitrogen and oxygen, correct? 79%, 21%, and then little bit traces of argon, krypton, xenon, all inert gases. Then carbon dioxide, CO, that is the inherent part because of combustion, so many things, and the water vapor. H2O is water vapor. Okay, then traces of neon beyond other gases, and most importantly particulate matters. Cannot get rid of that. Everywhere. Invisible but everywhere. Okay, this is the standard definition for atmospheric air. Then as per the ASHRAE definition, above 20,000 feet, your moisture content goes off, and what remains is only the dry air. Dry air means nitrogen, oxygen, argon, krypton, xenon, hydrogen, helium, everything. It's not only that nitrogen and oxygen. ऐसा नहीं है. Dry air means the gases, except water vapor and particulate matter. They get settled down at the lower altitude. So at higher altitude, what we get is only pure gases. We call it as dry air. Clear with this? Dry air does not mean only nitrogen, oxygen. We treat it as a nitrogen, oxygen only for the sake of simplicity, calculation purpose, but that is not the truth. Hydrogen also can be there, neon also can be there, nothing wrong in that. It's only that the water vapor and the particulate matter, they do not exist at such high altitudes. So we call it as dry air as a separate part and water vapor as a separate part. Particulate matters are solid things. We do not consider it as a working medium. Okay. Then the ASHRAE Handbook of Fundamentals, which whatever edition you may refer. There is a definition for the standard atmosphere which you should remember from the molecular weight point of view. So the atmosphere consists of dry air, one part, one component, which is allowed to be treated as a perfect gas. So PV is equal to MRT holds good. Okay. Gravitational constant 9.80665. We generally approximate at 9.81. Correct? Meter per second square. Then at sea level, the pressure is 1 atmosphere, but the temperature you can see that is 18 degrees Celsius. We generally take it as 27. Correct? So ASHRAE Handbook standardize the temperature, room temperature, room pressure, not room, what you call sea level. Atmospheric pressure is 1 atmosphere, okay, sea level. But atmospheric temperature is 18. It's not 27. Then the same temperature T decreases naturally when you go in the upward direction. Higher altitude, temperature reduces, we know. But the law or the governing equation given is T naught, which is basically 18 degrees Celsius, minus 0.0065 into Z, where Z has to be in meter. Okay, then whatever temperature you get in degrees Celsius only. This is not Kelvin scale. Rather, I would like to make it clear here itself at the very first instant to the entire class that air conditioning never considers Kelvin scale. Never, never. Do not use Kelvin scale anywhere when you tackle any numerical related to AC. Either it would be degree Celsius for MKS system or degree Fahrenheit for FPS system. Never use Kelvin scale anywhere in AC. And after the isothermal atmosphere, that means at some particular height, how much it is given? 11,000 meters. Correct? Your temperature would be minus 56.5 degrees Celsius. After that, your pressure variation P by P naught is given with that particular expression where A is a constant that is also given, Z is the altitude and the what I can see index 5.266. So if you know the Z, you can find out P. P naught is atmospheric one, T naught is atmospheric one. So what is the pressure? Let's say at the altitude of 15,000 meters. You can find out. Fine. So all these points are related to the atmospheric air and which are standardized by ASHRAE. And ISRE copies ASHRAE, Ulhasnagar edition. Even if you refer ISRE, you will get the same thing. Okay. Any doubt up to this? To anyone in the class? Online?
No, sir.
Okay. So major point to be seen, 18 degrees Celsius, not 27 degrees Celsius, and all the temperature parts are in degrees Celsius. Never use Kelvin. So here in the tabular form, I have given the information data, how the altitude changes, it goes on increasing, the temperature reduces, goes to the negative part. It should be minus 50, not minus 5. Okay, and pressure reduces 101.325, that is 1 atmosphere, 95, 89, 79, 70, blah blah. So pressure is reducing, temperature is reducing as your altitude height increases. Okay, it's a typing mistake for the last part. Here it should be 50. Okay, now the fundamental discussion for the moist air continues. The working substance of the air conditioning is the moist air, which is dry air, binary mixture of dry air plus water vapor. So whatever thermodynamics we had seen for the VSC, vapor absorption system, binary mixture, same is applicable over here. Okay, dry air plus water vapor. Now here you should remember about the molecular weight. Mole fraction is 1. Oxygen, nitrogen, argon and carbon dioxide only are considered. Remaining things are suitably neglected because the traces are very, very small. And the total mole fraction 20.95%, oxygen 78.09%, nitrogen, and then the remaining part argon 0.93%, carbon dioxide 0.03%. And accordingly partial molecular weight, the final molecular weight of air, dry air, here there is no moisture. Look at the table, no moisture. So for the dry air, the molecular weight taken is 28.966, generally which we take as 29. Correct? Exact value is 28.966. But when I consider the moist air, it drastically reduces to 18.016. This value is again standardized by Escher. Okay, so if you consider the dry air, okay, 29. But the working substance in air conditioning is the moist air, which is 18. So 29 to 18, large difference. Okay, always you should remember this value. Now accordingly gas constant, if it is a dry one, then universal gas constant divided by molecular weight. So you get over here 287, correct? 8314 is the universal gas constant, joule per mole per Kelvin or kilomole. Right? Similarly, you can find out the gas constant for the moist air and you can see the difference 287 to 462, drastically different. Fine. Now when I say moist air, then naturally it is a variable amount. No? It is a mixture of dry air plus water vapor. So water vapor can be 1%, can be 99%. Anything. So we consider this starting from 0. If 0 means what? No moist air. We call it as dry air. And 100% moist air, that means we call it as a saturated one. But here the main part, main thing to be considered, this is not 100% steam. Try to understand this. Very, very important. 100% steam does not mean that it is a moist air. There is another concept called as the saturation capacity. That means the maximum capacity of the air to handle, to absorb, to accommodate the moisture. That capacity is saturated. So in that sense, I have written over here 100%. कि इसके आगे नहीं जा सकता. Either there would be no moisture, so I will say 0, so that is dry air, or there will be some moisture which is the maximum holding capacity of the air. That is equivalent to 100% because that is maximum. So please do not get yourself confused that saturated 100% means entirely vapor. No. Am I clear? Any doubt to anyone?
No, sir.
Let's take a simple case. Whatever is the air right now around you, it is having some moisture. Is it the maximum capacity? Can I add further moisture? Yes or no? Depends. So how much maximum moisture the air can accommodate? That is equivalent to 100% or saturated. Okay, saturated 100% does not mean that it is purely steam. अगर यहाँ पे pure steam हो जाएगा तो हम जिएंगे कैसे? Oxygen ही नहीं है. So that is not 100%. 100% is a relative term. That is corresponding to the maximum amount of moisture this air can hold. And now you recollect from your basic physics, school level physics, or even day-to-day life. You say that humidity at the sea level is the largest, and humidity at Rajasthan, third desert, lowest, dry air. What is that basically? That the capacity of the dry air at Rajasthan Thar desert is the least. And the capacity of the air at the sea level to hold maximum moisture, that is why we call it as maximum humid. And that is why rate of perspiration in Mumbai or Madras or whatever, sea, nearby sea places, Calcutta, is the largest one. Correct? Sweating, highest at sea level. And that is hardly any sweating at Rajasthan, Gujarat border, Thar desert, Kathiawad. We use these words very casually. Dry air, humidity, but we do not know the actual meaning of them. Correct? Nagpur, anybody from Nagpur, Vidarbha, you say that the atmosphere is dry. What is the meaning? That the moisture content is very, very low. And then you say, Mumbai में पसीना बहुत आता है. क्यों आता है? Because the air is already at the saturated level. Saturated means what? The air is already having the maximum capacity to hold the moisture. You make any change in the temperature, it starts condensing out. And that is what is sweating. Are you getting it clear now? Any doubt to anyone?
Yes, sir.
Okay, so saturated here is a kind of misnomer. Again and again I am saying the same thing so that it should get or fit in your mind. 100% does not mean steam. Saturated moist air. That is the condition where the moist air may coexist. Very important word, coexist. It is not alone, coexist. Okay, in neutral equilibrium. What is neutral equilibrium? No chemical reaction. Okay, with associated condensed water. That means the moment you disturb this equilibrium, condensation starts. That means the moist air, which is holding that moisture, will start getting separated. So saturated moist air is the last condition after which separation starts. Okay, so this is very particularly related to the temperature. So I will say saturated moist air, that means there is some saturated temperature corresponding. You disturb that temperature even by 0.5 degree or 1 degree, condensation starts. And now you will realize, those who have visited for places like Mahabaleshwar, Shimla, Darjeeling, etc., etc., or Golimaro in places, everyone must have observed for the early morning atmosphere. ओस की बूंदे, दवाचे थेंब, moisture कहाँ से आया? That because of the low temperature, the atmospheric moisture, moist part in the atmospheric air, that got condensed. Generally we feel it on flowers in the garden, correct? So this is that exact thermodynamic phenomenon taking place at the early morning time, because in the night it is too cold, correct? And at that time, if the temperature goes below the saturation level of the moist air, then the moisture starts separating out, and what we call it as dew. Correct? English में dew बोलते, हिंदी में ओस, मराठी में सवाचे थे. I don't know about Gujarati. What is called? Gujarati में क्या बोलते हैं? I don't know. Fine. So looking back at the particular text matter, what I had written over here, the condition where the moist air is in coexistence, in equilibrium condition with the condensed water, means what? You disturb the equilibrium, you will get the condensed water out. Fine. Steam steam getting converted into the water form, vapor form getting converted into the liquid form. कब होगा? टेम्परेचर कम होगा तब. Simple, correct? Any doubt up to this part? How much time left? Any doubt to anyone online class?
No, sir.
Now we introduce with certain definitions which we would be using while deriving the final thermodynamic equations. The first definition is humidity ratio. Now read the definition very carefully. Mass of the water vapor, okay, whatever present in this air, per unit mass of dry air in the mixture. So if you observe the symbol used, it is mv upon ma, where the numerator is the mass of the water vapor, the denominator is mass of the dry air. They are different. Don't call this as unitless. It is kg of water per kg of dry air. इसको cancel नहीं करना है. If I find this cancelled in your paper, I will directly give 0 marks. It is not a unitless quantity. Am I clear? Kg of water per kg of dry air, two substances different. You cannot cancel. You can cancel the units only when both are related to the same substance. Here both the substances are different. Am I clear?
Yes, sir.
Second definition, degree of saturation. Here it is W, that means whatever you have calculated at that particular instant, at that particular place, divided by WS, where WS is given as the same humidity ratio, but at the saturation, इसका मतलब क्या हो गया? Maximum holding capacity of the moisture. Correct? For the same pressure and temperature, you are not allowed to change it. So let's say right now you people sitting in front of me in the classroom, whatever is the pressure and temperature over here, and there is some moisture. Is it a maximum one? No. Then the ratio of the some moisture here to the maximum moisture, that is degree of saturation. The name itself will give you the hint. Degree of saturation, extent of saturation, whether it is 40%, 90%, 10%, whatever it is. So the moisture which is right now available in this class is my regular condition W. And the maximum moisture this air in the class can hold is Ws. So your mu is percentage. Degree of saturation means naturally percentage, because your W will be always lesser than Ws. The moment W equal to Ws, that means saturation 100%, sea level. Are you getting it? Online class?
Yes, sir.
Third definition is relative humidity. Again, read the definition carefully. Defined by the letter phi, and it is expressed in the mole fractions, neither mass or any other thing. We define it in mole fraction. So mole fraction of water vapor in the mixture divided by the same mole fraction of water vapor at the saturation. And now you compare this with the degree of saturation. Degree of saturation is expressed in terms of W, where W itself is in terms of mass. And relative humidity phi is expressed in terms of the mole fraction. That's not mass. Correct? I hope you know about the difference. Kg per mole and, joule per mole and joule per gram are different. Correct? What is the bridging part? Molecular weight. Right? So phi and mu are different. Mu is in terms of masses, W basically in terms of masses. Phi is in terms of mole fraction. Otherwise, if you look at the text matter, it is same. Correct? Saturation at same pressure and temperature. But the units are different. Over here, one is expressed in terms of mass, the second is expressed in terms of mole fraction. Final unit is percentage. I agree. Because of the same person, same working substance. It's not changed. So W and WS of the same working air, and X and XS, that is also of the same working air. No problem. So final answer for mu is also percentage, for phi also percentage. But mu itself is designed in terms of mass ratios. Phi is defined in terms of mole fractions. Always you have to be very clear with the theory part. So relative humidity, now if I want to get rid of this mole fraction, मैं कहाँ से calculate करते बैठूंगा mole fraction? So I convert it suitably with some mathematical formula given by Ashray in terms of the humidity ratios, W and WS. So now looking at this particular expression, you will come to know that this is the bridging or gapping, bridging the gap for phi, that is relative humidity, mu, that is what you call degree of saturation, and W, that is humidity ratio. So this is my final expression, which will be having all three parameters. Any two will be given to you, third you have to calculate. Right? So this is a very, very fundamental equation. If I give you the value of phi and mu, then you can calculate W. W is standard, saturated. You can read it from steam table. Correct? So I can calculate W. If I give you W and mu, you can calculate phi. WS you can read from the steam table, it's a saturated one. So this is how you can use this expression to solve the numerical. Any doubt to anyone? Online class?
No, sir.
Very good. Now, a special condition, neither mu means what? Degree of saturation, nor phi means relative humidity, are defined when the temperature of the moist air exceeds the saturation temperature of the pure water, corresponding to the same pressure, moist air pressure. Then what happens? Say for example, sea level. In the sea level, exactly at this, just above the surface of the water, what we consider is entirely moisture. So over there, M is equal to 0. And your WS reaches to infinity. Correct? Even though your temperature may be 1 atmosphere and 100 degrees Celsius, exactly above the surface of the sea water, even though you reach to boiling point, still, you cannot define mu and phi. Because your Ma is 0. We assume that dry air, nothing is there. ये water level है, इसके exactly ऊपर. It is continuously in the equilibrium with the water part. So on the top it is vapor part, at the bottom it is liquid part. We consider no air. So at sea level, or rather I should not say sea level, sea water surface level, we cannot define mu and phi, because it's a dynamic equilibrium between the liquid and the vapor phase continuously going on. I do not have any information about the Ma part. We consider directly as 0. Okay, there are only two things remaining: liquid water, vapor water. It's a continuous dynamic equilibrium between the two phases, exactly at the water level surface, sea level. So over there, mu and phi cannot be defined. Very, very important from interview point of view. PSU interviews or any interviews. Okay, always remember this. How much time left? 2 minutes, 8 minutes. So, okay, I can complete this WBT. Now we will define certain temperatures. Okay. First temperature is the simple dry bulb temperature. You can read the definition. True temperature of the moist air at rest. Very important. It should ideally have velocity equal to 0. Natural circulation से थोड़ा बहुत कुछ होगा, that is acceptable. No forced convection allowed. Okay. At rest means actually theoretically it has to be like a stagnation point, but that is not possible practically. So natural convection से कुछ थोड़ा बहुत होगा, that is okay. But you should not put any fan or blower on while measuring the dBT. Am I clear? It's very, very important when we will do that experiment. Fine. So while measuring dBT, no forced convection component should come into picture. No fan, no blower, no what you call that, air. So क्या बोलते हैं छोटा यूनिट, हेयर ड्रायर टाइप. कलर वलर सुखाने के लिए यूज करते हैं, व्हाट यू कॉल दैट?
Blower.
नहीं, नॉट ब्लोअर. ब्लोअर इज लाइक इंडस्ट्रियल ब्लोअर, ह्यूज वन. कलर करने के बाद वार्निश वार्निश सुखाने के लिए जो यूज करते हैं, सिमिलर टू ब्लोअर ओनली, और इवन हेयर ड्रायर.
Hair dryer ही बोलते हैं.
So no such thing should be there at rest. Now the second definition, dew point temperature. How do we define this? It is the saturation temperature corresponding to the humidity ratio. Humidity ratio is the ratio of the masses. We have seen this, correct? Humidity ratio is H, no? We have seen this. ये वाला humidity ratio, H नहीं W, mv upon ma, kg of water per kg of dry air. So if that particular air condition goes to the saturation, then the saturation temperature at that particular pressure and the given humidity ratio, whatever is the saturation temperature, that is called as the dew point. इसका मतलब क्या हो गया? Basically that you start reducing the temperature by maintaining the amount of moisture same. Correct? Why moisture amount would change? Humidity ratio is same. So that means mv upon ma, kg of water per kg of dry air, that remains same. You start reducing the temperature, and the saturation temperature where this moisture will start getting separated out is the dew point. The name itself says na dew point. Uske aage dew. So this is the process which you can execute practically. Moist air mixture defined with some value of pressure P, humidity ratio W, and some diurnal temperature T. Okay, if the temperature is slowly reduced by holding the pressure and the humidity ratio constant, very, very important. You are not allowed to change the pressure. You are not allowed to change the vapor content. Then, whenever it reaches to the saturation value, what is the meaning of saturation value? Uske baad, moisture will start getting separated out. Air will be somewhere low density, upper ke side. Moisture will start getting down, condensed, collected at the bottom. That particular temperature is the dew point. Am I clear? Any doubt? इसका मतलब ये हो गया है कि for example this is the class, whatever is the moisture right now. Okay, you have to keep everything closed. No moisture can come in, no moisture can go out. Fine, no mass transfer. And you start reducing the temperature. Let's say right now this AC is working on a 20 degrees Celsius. Fine. So abhi, say for example 20 degrees. You close all the doors, windows, everything. No moisture, no mass comes in, no mass goes out. And you start reducing the temperature, 19, 18, 17, 16, 15. And let's say, for example, at 14, you start feeling like wet on the palm. That means it is the start of condensation. So 14 degrees Celsius will be the dew point. This is what exactly I said as the example. Mahabaleshwar or anywhere, any cold place. At the early morning, you always feel the dew. कहाँ से आता है? यहाँ से आता है because your temperature is reduced. Moisture is constant. Am I clear, online people?
Yes, sir.
Okay, see our time over. So we'll stop over here. The next discussion next week. Any doubt to anyone? Please ask the doubts whenever you have as far as air conditioning is concerned. It's very interesting, provided you must be clear with the concepts. Your entire viva for the lab evaluation will be based on these concepts only. I'm not going to ask anything related to the experiments which you do. Okay, I will be asking all the questions related to your day-to-day life. So over there you must be able enough to defend. Fine. So we are meeting at 2 o'clock for the lab. Let me check that equipment is having a problem as far as the refrigerant is concerned. There is a leakage found. So because of that, the refrigerant is lost. So I will try to start it. Even if we get some kind of cooling effect, fine. Because anyways, readings so different here. You have to change the evaporator pressure and the condenser pressure. I will try to see if the unit goes into the working condition. I will give you one reading. The remaining we can do from some other references. So I will be there at 2 o'clock. We will start the equipment, see if it works properly. Even if we get a little bit of refrigeration effect, fine. That would serve as one unit, one reading. And if it won't at all, then I will see what to do. There is one old unit also that is also having problem as far as the refrigeration is concerned. Whenever a refrigeration unit is like kept idle, then there are always the gas leakages. That is why everywhere in every house we keep the refrigerator unit continuously working. If you put it off for a certain time, then there are leakages and the refrigerant goes out. That is the main problem. Every year I have to fill it. That's a long procedure. Anyways, the administrative issues are different. So be there at 2 o'clock. We will start the unit. You must be having mobile camera, ना? वो चला तो इन लोग को कैमरा पे दिखा दीजिए. ठीक है? चलो. Okay, fine. Should I end the meet?
Yes, sir.
Okay, fine.